This is just a short video to explain how I assemble my Biochar Retort using a couple of reclaimed oil drums. So the first thing in here, this is the 60-litre oil drum, and this forms the outside of the retort. So there's a 60-litre drum, and then the smaller drum is 25-litre, and then that's the drum that fits inside the retort. So that's the one that's loaded with feedstock, which will become the actual biochar of the charcoal when the burn is finished. And in the space between the inside drum and the outside drum, that's where feedstock's added, which is burnt from the top. So it's top lit updraft retort. That burns down. As it burns down, it heats up the timber that's inside the inner drum. That produces wood gas. The wood gas ignites and then burns around the outside chamber. So it's the actual combination of that initial load in this drum, which actually provides enough heat to char the wood in the inner drum. So there's a number of items. So you've got two drums. These are little standoffs. These are little pieces of angeline, and they just fit underneath. I used, I think it's 38mm by 38mm Dexian angle, which is like a punched angle that's used for kind of constructing shelves and workbenches and things like that. I just tried to use as much reclaimed material as I could find, so this is sort of scrap material, so I haven't actually gone out and bought anything in particular. This is probably the most difficult part of the thing to actually build. This is I use 3mm mild steel plate, and I cut it out carefully. We use an angle grinder, and the hole in the centre, I didn't have a hole saw, the 125mm diameter, so in the end I just I think I chain drilled and then used the cold chisel to sort of kind of cut out the disc in the centre. Two ways of doing this. This is like a kind of ducting, a flange sort of spigot, and these are sized to fit inside the ducting itself. You can use any kind of sizes of ducting. This shown here is 125mm, which is sort of 5 inches, and that's probably ideal. And so obviously you need to source a pipe or ducting flange that fits inside. Alternatively, if you don't want to spend the money on that, you can probably find laying around some angle plates or kitchen brackets or something like that. The kind of brackets that you use to support the worktop against the wall, they're quite good. But if you're using these things, you need to drill holes and then corresponding holes into the top, so you can use M4 or M5 machine screws and washers and nuts. They're going to be subject to heat, so like all things, I try and use reclaimed materials because it's got a limited lifespan. You'll get a number of burns, and the main issue is that the inner drum won't actually hold gas after, I don't know how many burns, 24 burns, something like that, but you'll get kilos of charcoal, and as the charcoal is a long-term sort of benefit in the soil, then I think it's worth doing. And if you can find these, I think they are from a hydraulics engineering company, and they were for hydraulic fluid. The other ones, these are 25 litres, so they'll be for oils and various sort of solvents and things like that. The outside ones are just, they can be dry goods ones, or which got a clip top, or I just used the liquid one, which was just an oil drum, a half-size oil drum. Like these things, you can actually upscale this. You could use the larger drum, the 60-litre drum is the inner, and then a 205-litre oil drum, a full-size 55 or 45 gallon oil drum for the outside. But I wanted to do this just as a trial, so I wanted to actually get one of these size drums, but they had the smaller ones, so I kind of scaled to suit. So if you can't find the pipe, or the not pipe, the ducting spigot, you could just use these angle brackets. So it's quite straightforward. I use a jigsaw to cut the top of the drums off. If you look at the drum, they're made out of quite thin sheet metal, and it's rolled over the top, and you'll get this kind of seam. This is quite thick because there's about 3 layers of metal where it's folded over on itself. So I use a jigsaw rested the base of the jigsaw on the top of that flange, and then just used that to guide the blade round, and then I cut the top off to make a kind of a bottom, because when I use this drum with the top cut off, I actually invert it, load it up. If you imagine this is spun round the other way, so I rotate it round, so it's full up with feedstock, and then the little top that I cut off, I just sit that down on it, and so that creates a lid on the base of the drum. Because I use jigsaw, there is a thin kerf, so when that goes inside that drum, there is around about 1.5 or 2 millimeter gap. That's sufficient to actually have enough space for the wood gases to come out. So I didn't drill any additional holes around the outside, or I didn't punch any holes in this part itself. So it's quite a straightforward way of doing it. Likewise, to cut the top off the outer drum, I used this jigsaw and cut it off in the same. The piece that I cut out, I just sat on the base underneath these little pieces. I thought, if anything, it's just another layer of kind of protection from the heat, and it might make the drum last a little bit longer, but I don't know if that's important at all. So the flue itself, this is 125mm. I think that's about the optimum size for this kind of size retort, because when this is in full retort mode and there's lots of wood gas coming out from the inner drum, and then that's really producing lots and lots of heat, you've got quite a fast flow of gases through here. Obviously, with a flat plate on top, there isn't any kind of aerodynamic kind of effect. So it's, if you imagine the heat's coming out from the bottom here, it's rushing up here quite fast, it's hitting that kind of, and it's going to have to take a 90-degree turn. Obviously, if you were making one of these from scratch and you're sourcing materials, it would be nice to have that cut out and have more of a conical fitting, so it's kind of funnels the gas into the flue. But what I have found is, nearer the end of the burn, as there's less kind of heat there, there's a little bit of gas, there isn't that much oxygen. What I tend to do is stand this lid just on a couple of battens of timber, just to make some secondary air in here, so it's just got enough just to pull through. Because obviously this is cooling down, and you haven't got that kind of heat cycling through it, so it's good to just have a little bit of extra heat, or a little bit of extra kind of flow of air. I haven't shown that on these drawings, but this is my drawing. I'll make that available in the links below. I'm showing this standing on a paving slab as well. Obviously, you need a nice level slab or a nice heat-proof surface to stand this thing on. So paving slabs are kind of readily available, and they'll probably crack after a while from the heat, but it's quite easy to stand the whole thing on bricks as well, just to raise it up a little bit. If you do raise it up a little bit on bricks, that just gives you a little bit more airflow as well, because you'll find that it's standing up a little bit higher, so there's more of a breeze. As you get closer to the ground, you won't get that quite so much. But what I have shown on here is just 2 larger air holes, 75mm, which are punched into this outer drum. I used a hole saw, and then I also cut 8 25mm holes just around the circumference on this drum as well, around about 50mm up from the bottom edge. I used a sheet metal punch to cut the smaller holes, because I thought by the time you've drilled the holes, it takes a bit more time. It's quite quick just to punch holes in itself. I also added some secondary holes. I know I'm showing this on a diagram. A couple in the flue and a couple 50mm from the top, only 25mm holes, and I punched 4 of those. I don't really know if that's important, but if your feedstock isn't quite so dry, it might be an idea to have a little bit more airflow, but you can achieve the same just by possibly using a little piece of angle iron, just standing under the lid, and that gives you a little bit more control for the burn as well. If you notice the burn is really effective, and there's wood gas being produced, and there's no gases or smoke around the outside of the drum, and you'll notice a big plume of flame coming from the top of the flue, you can kind of see that it's burning nice and efficiently. If there's lots of white or grey sort of smoke tinge, sort of brown tinged smoke coming out the top, there's not enough oxygen, and that's the wood gas. So what you might want to do is just crack open that lid a little fraction, so you can just move it to one side. so that will allow a little bit more air to get through, or you could use a little piece of angle iron or even a piece of wood just to prop that up, so it's just moved to one side as well, so you can get a little bit of air coming in here. So it's quite straightforward. One thing to bear in mind, if you're using a large flue pipe, and this one obviously is, I'd suggest on here this is shown about 1.5 meters, but anything over a meter is probably ideal really. But what it might be a nice idea if you can find something from a scrapyard or something in a skip, you can sort of source a piece of spiral sheet metal ducting. Ideally I'd have a shorter piece, and then this would sleeve over that, because obviously once this is on that plate it's going to be quite tall, and all these things are quite hot, so you've got to bear in mind it's not going to be that stable. On my one I'm using 125 millimeters, and that's got quite a nice sort of footprint on there, and it's cut off nice and square, so it stands quite stable on top. And I've used 4 of these angle plates, so they're bolted to the 100mm piece of pipe, but then the 100mm pipe is only around about 600 millimeters, and then I use this as a sort of extension, just to kind of, once the burn's all going along, and you haven't got to kind of keep popping the lid off to check out, or when I initially start the burn, I'll start with the retort open. So you load the feedstock around it, you fuel it up from the top, and then you want to kind of make sure that those embers are going down the sides, so you might want to rake it around, get a little bit more air into it, and then at that point you'll be taking that lid off, and you might want to position some timber under there just to get a little bit of airflow. But once that is hot, and then you'll see the outside of the drum glowing red hot as the wood and the feedstock burns down. At that point you won't need to take that lid off until that red glow is right around the base of the drum, and that's the last kind of stage of the burn. That's when the feedstock or the source timber in there has actually charred, and it's just the last little residue of wood gas that's coming out. At that point you might want to kind of rake around here and just make sure there's a nice sort of even burn all around the bottom of that drum. And also what I'll do is that 75mm hole in there, I'll use that one to just add a little bit more timber, so you're using it like a little stove just to make sure there's enough timber around there to ignite the wood gases. But when it's very low, you can take that plate off, and the flue, you won't really need that, and then you can just kind of observe what's happening. If you see a nice fierce flame burning, it gives you an idea there's maybe 10-15 minutes left. If there's just a little tiny kind of flicker of flame, a bit like a kind of match, you pretty much you're ready to go. If you want to fire up the retort again, what I'd do is I'll tip the whole thing over, so you'll need a reasonable area. I've just got some reclaimed slabs on the allotment that I use as a sort of utility area, and that's quite a good space for using the retort. So you want a stout pair of leather boots, ideally steel toe boots that have got oil and heat resistant soles, and then you can just push the thing over it. The inner drum's going to be hot, but the outer drum, by that time, it's only going to be the base of it that's hot. Once you tip it over, get a galvanized watering can and just quench all the charcoal, just to kind of cool it right down, and then that itself will cool that in a drum. And you obviously want to check it. We'll just use the back of your hand once it's finished steaming, just to make sure there's no heat before you actually move it. And then obviously you can set this up again, so you'll set this drum up, load the inner drum, and then you can kind of fuel it from the top again. So that's just a few little ideas. This piece of mild steel, it might be an idea to get a 6mm or 8mm, something like that, and possibly you can go on eBay and there'll be engineering companies that can plasma cut or laser cut that to size. It might be worth the investment if you're going to do this for any number of burns. What I'd suggest though, familiarise yourself with the process. Make one of these as a kind of starter, and if you kind of think, oh, it's too much effort, it's not really for me, there might be some way where you can pick up charcoal for a small sort of fee. but I kind of like the process, and I like using reclaimed materials, and I get lots of offcuts of softwood and hardwood, so it's a good way of using those on the allotment as well. And obviously with biochar, it's organic material which you can use in the soil, but once it's in that charcoal form, it has got long-term benefits as well. So it's not the kind of thing like as opposed to getting a 25-litre bag of compost. Once you put that in the soil, it will continue to break down, and there won't be anything left after a number of years. With the charcoal, that's got a cumulative effect as well, so each year that will have ongoing gains. So even though it's the quantities you're looking at, this is quite small, so you've only got a 25-litre container in a drum. Obviously you'll fill that up with less than 25 litres of timber, because there'll be air spaces, and by the time it's charred it will shrink down, so it's quite hard to sort of quantify how much charcoal you'll get per burn. But obviously using free materials, so it's something you can do. And you can obviously do other things whilst the burn's in progress as well, so it's not that time consuming just to load the thing and empty the thing, and then obviously you've got that quantity of charcoal. And over a year you can produce, if you're burning once a month or something like that, I wouldn't really have thought, unless you've got a large or a small holding or a small farm, there's no need for anything really larger. I mean, unless you're working with other gardens and community gardens and allotment societies and things like that. So personally, I think all allotments should have this kind of technology, and they should invest, and when they have their kind of open days and fundraisers, I think it's something they should be investing in. I think it's interesting, and it's a good sort of educational tool as well. So it's very straightforward, but I thought I'd just show how I make these, how to use jigsaw to cut the lid off, how I use that little lid to seal up that inner drum, how to kind of punching holes and having these little standoffs, because it's easy to have a drawing, but sometimes it's better if you can kind of talk through. But obviously there's obviously elements of hazard involved in these things, so if you're familiar with sort of camping and campfires, and you've got that kind of caution about using fires and starting fires, and you're working in a well ventilated area outside, and you're kind of doing this in a controlled environment as well, so you haven't got lots of trip hazards and things. If you use any lighter fluids or meths or anything to ignite this, you're making sure they're in a sealed container, they're well away from any kind of naked flames as well. But it's very controlled. It's far more controlled than the campfire, because it's actually in this closed vessel as well, so you're not going to get stray timbers dropping out and falling onto anything and igniting anything else as well. It's only at the end of the burn when you need to empty this thing out, but if you're only doing one burn, you can just take the flue off, put a couple of bricks on top or whatever, or you could even use the lid from the oil drum and a paving slab or something like that to weigh it down, and it will just self-extinguish after the charcoal cools down enough, so it isn't at that sort of critical temperature where it ignites on its own. With charcoal, that's one thing to bear in mind. If you've got a big container of charcoal, the inner drum here, if you take that out when it's finished burning and then turn it out the other way so oxygen can get in, it will want to ignite on its own. So what you can do is just keep it that way up so the air can't get into it, because this is hot, so the hot gases are actually pushing out from the bottom, so that's forcing the oxygen away, so the oxygen can't work against that to get inside the container. But if you do take one of these out, you might have a number of these containers, so you can have some set up ready to go, one in use, and then you might have some kindling and things that you're storing in these, so when you fire the thing up, you can just quickly swap that out into the next one. But yeah, bear in mind, if when you take that out, you just want to put a paving slab or something on it just to keep the air out, and that should be sufficient. Okay, I hope that's answered any questions, but it's very straightforward, and if you can find these drums locally available for free, even better. I think I paid £10 for the two, but I picked up a few of these because he had I wanted to get this size drum, but he had a few of these, so I picked up the ones he had. As a friend of mine, he works in a workshop making fire doors, and they source their adhesives adhesives, and these are size 25 litre containers as well. So they're readily available, but you might need to do a few kind of inquiries online or local kind of sharing groups, or Gumtree or FreeCycle or something like that. But there you go. Thank you.